Hello, everyone. Thanks to go to the ML privacy session. In this session, we have 3 terrific papers. And the first paper is Duty to Forget, a Right to be Assured, Exposing Vulnerabilities in Machine Unlearning Services. And the speaker will be Hongshen. Hongshen is a postdoc researcher at Data61, CSIRO from Australia. And the floor is yours, Hongshen. Yeah.
Hello, everyone. So my name is Hongshen. So today I will present the paper, A Duty to Forget, a Right to be Assured, Exposing Vulnerability in Machine Learning Services. This work is done with my collaborators Shuo Wang from CSIRO, Jiamin Chang from University of New South Wales, Hao Nanzhong from University of South Wales, and Roxy Sun from CSIRO, and Shuang Hao from University of Texas at Dallas, and Hao Jingzhu from Shanghai Jiaotong University, and Minghui Xue from CSIRO. So yeah, we can go next page. Sorry, yeah, I should use this one. I want to begin with my presentation by introducing the ecosystem of machine learning as a service, which is quite popular in nowadays. So usually in machine learning as a service, we have users who generates a large amount of data, include like images, emails, audios, and text. And these data are provided to a developer whose responsibility is to use advanced training algorithms and advanced model actors to train a model. And once the model is trained, the model is provided to the server. And when the server is ready, then the server can provide services to users. But the problem is, what if the users regret? So I want my data to be deleted. This can happens a lot in reality. And there could be lots of reasons. The first reason could be like data privacy, like the generated data contain lots of the private information of the users. And also data security is a problem. For example, like you don't want your email address to expose like in the internet because you can receive like spam emails or phishing emails. And I want my data to be deleted can give users a sense of secure because they have control over their personal information. And sometimes this information can also contain like past mistakes or embarrassing information, so the users want the data to be deleted. And last is the most important is because this is the right given by the legal regulations, like the most well-known legal, like the GDPR. So what can we do is, fortunately, we have machine learning techniques. So machine learning techniques is when the model is trained on the training data, and I want to remove part of the data from the trained model. Then I can use machine learning techniques to obtain an unlearned model. And the amazing thing here is the unlearned model is very close to the model retrained on the remaining data. So use one sentence to describe machine learning is machine learning can remove the influence of unlearned data efficiently and effectively. So would it be an amazing thing if machine learning can be deployed as a service? So the normal business in the machine learning as a service, the ecosystem is the normal user can submit the query access to the server, and the server can provide the prediction results to the normal user. Like we interact with the ChatGPT, we submit prompt text, and then the ChatGPT will give us the response. So it would be amazing if we have machine learning services. So in machine learning services, is like some data owner, we consider them as unlearning users. So one day, if they feel unhappy, then these users can submit deletion request to the server, and the server will perform model unlearning. But the thing is, what could problems occur? So we ask the key question, so what could be wrong if there is an unlearning user submitting potential malicious deletion request? And what consequence malicious deletion request can bring? This is the question we want to investigate. So we identify a vulnerability called over-unlearning. So before we introduce over-unlearning, we need to introduce what we need to define, like what is normal unlearning. So normal unlearning means when the user submit the normal data, which means the data is not corrupted, then usually using machine learning techniques, we obtain the unlearned model, and usually the unlearned model compared to the original trained model, the model utility is preserved or slightly reduced. So what is over-unlearning? So over-unlearning is the focus of the word over. So over means more information is deleted than expected. And if we look at the utility of the model, then we will find the unlearned model generated by over-unlearning, the model utility was suddenly reduced. And over-unlearning is achieved by the malicious unlearning user by crafting the original unlearned data. So the technical challenges here is how can we achieve over-unlearning? And there are two technical challenges. One is it is very difficult to quantify how much information is contained in a single data point. And even we can answer the first question, it is very difficult to quantify how a data point may influence the model. So we start with first explanation using blending as a naive over-unlearning method. So the intuition is we can incorporate the information of an additional sample into the unlearned sample using the blending technique. And actually, this is quite simple. X prime equals to R equals to 8, X plus 1 minus A plus XB. So XB is the additional sample. So here is the example. If we set the alpha, the blending parameter as 0.5, then we can blend the plane into the cat. But we will show that this naive method doesn't work effectively. So we propose pushing as advanced over-unlearning. So what is pushing method? So we have a key intuition. The points near the decision boundary of the model is more informative than the points far away from that. So for example, like here, the point A and the point B, they are very far away from the main point in the class 1 and the class 2. And because these points are rare for the whole samples in this class, then they are more informative. So we have two pushing strategies. And pushing one is we can push the unlearned sample near the decision boundary, but we don't want the sample across it. So for example, we can move some samples in class 1 to the decision boundary of class 1 between class 1 and class 2, or between class 1 and class 3. This is pushing 1. And the pushing 2 is, compared to pushing 1, we want to push the unlearned sample just across the decision boundary. So the technical issue is how can we achieve pushing? But we found that moving a sample towards the decision boundary is well studied in adversarial example attacks. So we can use black box adversarial attack techniques to achieve pushing. So put simply, we can add small perturbations to the original unlearned sample, and then we have a distance function to define like how close the sample is close to the decision boundary of the model. So we have done quite a lot of experience. And here, the utility metric, we use the accuracy of the model to evaluate the model performance. And the baseline here, we want to compare the model obtained by over-unlearning, compare it with the model obtained with normal unlearning. And the unlearning method here, we use approximate unlearning methods to evaluate the experience, because we consider exact unlearning methods, they are not suitable in the machine learning as a service ecosystem. And we do have some restraint on the number of the unlearned sample because we consider the capability of the attacker is limited. So we consider the number of unlearned samples is no more than 50% of a class. And the blending, in the experience of blending is we blend samples in the class B to A, and we check how the machine learning can influence the model's accuracy on B, on the class B. And in pushing is we move the samples in class A to the decision boundary of the other classes and to see how the model's accuracy will change on the class A. So is blending effective? So, but unfortunately not. So blending is not stable to achieve over-learning. And our hypothesis here is the blending method does not change the decision boundary of the model too much through unlearning. And this could be because we unlearned these samples generated by blending, but there are lots of the alternative samples in the remaining data, so blending does not change the decision boundary too much, so it's not very effective. But is pushing effective? So pushing is very reliable and is always effective. So this confirms the data points close to the decision boundary are very important in machine learning. So here we conduct experience on 3 datasets, and the blue bar is the model performance obtained by normal learning, and the green bar is the model performance obtained by unlearning malicious generated unlearned samples. And we found that the utility of the model obtained in pushing 1 and pushing 2 are less than normal learning. And sometimes the model become useless because they are dramatically utility loss in pushing 1 and pushing 2. For example, like in a CIFAR 10 dataset. But we want to further ask, pushing can be more dangerous than just utility reduction. So we ask, what if we push all the unlearned sample to a particular decision boundary? So for example, like here, if we unlearning samples in class 3, if we push all the samples to the decision boundary between class 2 and class 3, so what will happen? So the result is we can control the classification behavior of the unlearned model. So here, the class A is the label of the unlearned data, and the class B is the target label. So which means we're moving all the unlearned sample to near the decision boundary of class B. And we test the model's performance on the testing example in the class A. So there's 1,000 testing sample of class A in total. And we found that before unlearning, there are more than 800 samples can be correctly identified, classified as class A. And in normal unlearning, only 5 examples will be misclassified from class A to class B. But if we're using pushing 1 and pushing 2, then there could be over hundreds of samples. The original label is A, but the model will predict it as B. So this means the malicious unlearning user can control the behavior of the server's model. So here are 3 takeaways. So first takeaway is pushing is a reliable and effective way for over-learning. And this confirms data points near the decision boundary have a high impact on machine learning. And the second one, although I haven't shown the results here, but a larger number of unlearned samples enable more effective unlearning because the malicious user can craft more samples. And the third one is the model's behavior might be controlled through over-learning. So discussion here, first we want to discuss is is there any layer possible defense against over-unlearning? So because as we have introduced, to achieve over-unlearning, the malicious unlearning user must craft the original unlearned sample. So hashing could be a possible defense. So which means when the user submit an unlearned sample, then the server can check the hash value of the sample, whether they can match with the original sample. And the second one is the membership inference technique. The server may consider membership inference technique to verify whether the unlearned sample is the training sample of the model or not. If it is not, then maybe the server can reject the unlearning request. And the third one is anomaly detection. If we consider the crafted sample as a normal sample, then we can use anomaly detection methods to detect it. And the second discussion we want to convey is, can over-unlearning be successful in exact unlearning? In my opinion, there is a possibility, but at least maybe we need to, through poisoning, at least can increase the difficulty of the, but at least can increase the difficulty of the attacker, because the attacker required to poison the training data set first and then submit the unlearning request to achieve over-unlearning. And the third one is, it could be more than model utility in over-unlearning, because like a model robustness is very important as a property of a model. So how malicious unlearning may affect the robustness, this can be a future work for us to do. So that's all of my talk, and thank you for your attention. And for any questions, you can reach me via the email address.
Okay, thanks for Hongshen's presentation. Any question from the audience?
Thanks for the talk. So in one of your slides, you mentioned that the points closer to the boundaries are more informative. Just wondering if you have an example for that. It doesn't sound very straightforward to me. So.
Yeah. So here, my intuition is like, if you delete some samples in the circle, then because there are lots of the samples are very close, because all the samples are very close in the green circle or the blue circle. So delete 1 or 2 will not influence the model's decision bound too much, because we consider where the decision boundary of the model is shaped. Like here is because the existence of the point A and the point B. So if you delete some points are far away from the decision boundary, then this should be fine. That will not influence the decision boundary too much.
Gotcha. Thank you.
Any other question? Okay, so let's thank Hongshen again for his presentation.